Hello everyone. Today we are going to understand the working of the normal LCD. And this is going to be a little complicated, but once you learn things, everything should be perfectly fine. You will let us see this layout of the pins of this LCD screen. Uh, the first pin starting from the left hand side is basically the ground pin. Okay, so that means I connect the ground to this pin. Very simple, no problem. Next is a 5 volt VCC. That is also not a problem. You just connect the 5 volt VCC to this. Number 3 pin or the next pin is basically a display contrast pin. Display contrast pin basically displays a contrast. Uh, this pin is basically used to set the contrast. Contrast is if the things are not actually visible on the screen very much, so we can use a potentiometer to increase or decrease this display potential, the display contrast. So V0 actually gets the wiper pin of the potentiometer. That is also not a very big problem. The RS, that is the register select or the read write and the enable. These are three pins that you need to use. The in between one, that is the read write pin, is optional. That means you may or may not use it, but you need to use the register select and the enable. Then we have 8 data pins. So that means they start from D0 going on to D7. So these are all pins starting from here to this place. And the last two are the anode pin and the cathode pin. These are basically used for the backlighting. So what we normally do is either use backlighting or use V0. Okay, so either of them. So either we backlight it or we use the display contrast. So if we are using the display contrast, then we need not use anode and cathode. We can leave them. So that means there are three pins that we can optionally leave. That is anode, cathode, and the read write. Okay. So if anode, cathode are used, then V0 needs to be grounded. So that means we are not using a potentiometer here to change the contrast, but we will ground it. So I and for this anode and cathode, these are basically just positive and negative voltage. So anode is connected to the positive 5 volts through a resistance, and cathode is connected to the ground. So we can imagine that there are three pins to the ground. Cathode is to the ground, V0 is to the ground, and ground is to the ground. And if you are not using anode and cathode, then V0 is actually the wiper of the potentiometer. I've just given you the list of all the pins here, and you can see them on the screen. Now I'm listing it again over here, and let me explain. The liquid crystal display pins, first is ground, second is VCC, that is positive voltage. I can write over here, this is positive 5 volts. The third is the contrast pin, if it needs to be grounded if backlight is used. Okay. Then we have the register select, that is RS, RW, and EN. So these are out of the three, RW is optional. You may or may not use it. D0 to D7 are the data pins, and 15 pin number 15 is actually the anode, which needs to be connected to, if you want to use, it is connected through to the 5 volts through a resistor. This is optional. Again, cathode is also optional. This is actually grounded. 7 to 14 are data pins, so that means pin number 7 to pin number 14, that is these are data pins, all of them. And you can use either all of them or four of them. Okay, I'll explain. Okay, 15 and 16, as I told you, are for backlighting, and the pin number 4 to 14 need to be connected to the Arduino. So that means this 4 to 14. These need to be connected to the Arduino using the digital pins. Okay, and we need to know where those digital pins are. Okay, so we need to specify that RS is connected to which digital pin, EN is connected to which digital pin, and so on and so forth. We need to specify that. All right. This is the constructor which we basically need for creating the LCD. Okay. So just wait a minute. Okay, now we will start coding now. The first thing that you need to do is include a header file. So I'll say include LiquidCrystal.h. Okay. Not LiquidCrystal underscore I2C.h. So that was for the other one. Okay. Now we need to create an object of liquid crystal type. So how do we do it? So we'll just use liquid crystal. By the way, crystal, the C is capital here. So I'll say liquid crystal LCD. We'll also call it an LCD. Okay. Now we need to specify what? We need to specify the, I had shown you the constructor list of constructors there. So okay, this is what we need to specify. Now basically this is the variable containing the pin number for the RS. This is for enable. This is for the D456 pins. Let us create those variables first. So I'll say RS is equal to, let's start off by giving them pin numbers. Let's start them with 4, 5, 6, 7. Let's start it with 2, 3. Okay. So I'll create RS with the value of 2, enable variable with the value of 3, D4 with the value of 4. So this is connected to pin number 4. D5 is connected to pin number 5. D6 is connected to, for convenience sake, I'm giving the same numbers. And D7 is connected to pin number 7. So there is no problem with PWM or whatever. So all of them are okay. Now, this is how you actually create the object of liquid crystal type. So what we actually did was, so RS pin of our liquid crystal will be actually connected to pin number 2 and so on and so forth. After this, what do we need to do? Let us start creating the setup function. And setup function basically will have one line called LCD.begin. So this has a big, very simple function to call. In the other LCD, we said LCD.init. Over here, we are writing LCD.begin because this is the other LCD now. Let's start off with the loop now. In the loop function, in the loop function, uh, we also we have the set cursor function. So we'll say set cursor and 0 comma 0. The system is exactly the same as the previous one, and we will have LCD.write. In fact, we had LCD.print in the other one. This is LCD.write. So we'll write welcome to, and we have this. Now, let me change the cursor now. LCD.set cursor to 0 comma 1. That means I'm on the second row now. and I'll say LCD.write. Welcome to Tinkercad. Okay. All right. What else? Okay, let's see this part only. Okay, let's see how this thing is working. We need to now set up the system now. Okay, let us bring our LCD in now. So LCD, we are not using I2C now. We are using the difficult one. Okay, let us. We have the LCD. We will use. Uh, we will use a breadboard. Okay. You can see that the breadboard fits automatically onto, the LCD screen fits onto the breadboard, and it is automatically connected. So let's have the connections. Let's have the connection. Let me have it on the little bit on the right hand side. Uh, let us have the connections. Let me put this aside and let's do the voltage connections first. Let's connect the 5 volts and the ground to the breadboard. Let's connect. Let's color them properly. These are okay. All right. So now let us now connect negative to negative and positive to positive, so that both the rails are now connected. So we have power everywhere. Let's color this as black. So this is negative. Shall we connect this here? Yes, we will connect this here. Okay, let's keep it. The first one is the ground, so let us directly connect this to ground. So you can see that all these pins are connected, so automatically all these pins are connected to the ground. This is voltage plus 5 volt, so this is connected to plus 5. Okay, do we want the LED, the backlighting to be done? Yes, we can have the backlighting to be done. This is the cathode, so let us connect the cathode to the negative. So it is connected to the negative. And as I said, the anode is connected through a resistor to the positive. So this is connected through a resistor to the positive. That's directly connected. Alright, what about the others now? Uh, as we had put in our code, RS was connected to pin number 2 and enable to 3. So let's connect RS. RS is this one. This is connected to pin number 2. So let's connect it to pin number 2. Number 2. RW, we are not going to use it. For example, in our code, we have not used RW. So we are not going to use RW pin here also. So no problem. Next is enable pin. Enable pin is connected to pin number 4. Sorry, pin number 3. So I'll connect it to pin number 3. I'll beautify it a little later. And then I'm going to use my last 4 pins of my data pins, that is 4, 5, 6, 7, to pin number 4, 5, 6, 7. So let's connect them to pin number 4, 5, 6, 7. This is to 4. This is connected to 5. This is connected to 6. Very convenient. And 7 is connected to 7. Let's have all of them as this color. This is again this color. Again this color. We should have connected the colored the first one wire, and every wire would have been connected. Let's would have been colored. Let's color them differently. These ones. Let's color them differently. So are all the pins connected? Yes. RW is optional. I've left it. V0. As I'm using the backlighting, I will ground this now. So V0 is to be grounded. Yes, it is grounded now. I think all cabling is done. Do I need anything else? I don't think I need anything else. Let's start the simulation and see what happens. Okay, there is some problem in the code. D6 was not defined. Did I not define D6? We have defined D6. The problem is here. I should have put an equal to sign here. Okay, let's run this again. Uh, liquid LiquidCrystal.h. Okay, I have changed the coding. I have renamed the LCD to my LCD. I think LCD is reserved for it, so it was not working there. So I've named it as my LCD. Rest everything remains the same. And when we so we have created an object called MyLCD, so it becomes MyLCD.begin and MyLCD.setCursor and so on and so forth. Let us check it out. Let us start the simulation and see. Yes, it is working perfectly fine. Now this was the situation in which we are using a backlighting here. So we are using a backlight here. Okay. Suppose I don't want to backlight, and I actually want to uh, use a potentiometer or something to change the brightness. So for that, we will need to remove the anode and cathode. So let us just remove them and see how it will actually show. That is showing with a very low contrast. Okay, so let us learn how to use the V0 pin now. V0 pin, we will remove we will remove the grounding for V0 pin. Let's see what it shows right now. It is not showing anything at all. So let's learn how to use the potentiometer. Let's bring in a potentiometer. All right, this part done. Let's start fitting this in somewhere. I'll fit it in here. I'll connect the ground to this one, which will be actually connected to terminal 1 of my display. This will be connected to this one with red. Yes. Now I will place my potentiometer here. So you can see now that the terminal 1 is connected to ground and terminal 2 is connected to positive. Where is the wiper going to be connected to now? The wiper is going to be connected to V0 now. Connected to V0. Let's color it differently now. Okay. Let's start the simulation and see how things happen. Yeah, it has started off with a very low contrast. Alright, we need to work that out now. It is actually doing the opposite. It is reducing the contrast. Okay, what I have done now is that I have connected the terminal 2 to positive, terminal 2 to negative. Okay, this is negative now. is negative now, and this is positive. And I've connected terminal 2 to negative and terminal 1 to positive. Why? Because the wiper was working in the opposite fashion. So the resistance remains the same, and let us check the simulation. And right now it is the contrast is the maximum, and the contrast goes off suddenly. Yes, this is how this is working in Tinkercad. So you can imagine when you are actually working on the actual thing, you can actually use the potentiometer properly. The thing will show the contrast properly on the screen. So we have seen both the things now. We have seen how we had connected uh, the backlighting stuff. So when we use the backlight stuff, it was actually backlit and there was no need for contrast. At that time, V0 was connected to ground. Now what we did was we now removed the backlighting, and after removing backlighting, we put in the potentiometer. And the potentiometer, you can see how it is connected. You can see now that it's terminal 1 is connected to the positive, terminal 2 to negative. Normally it is the other way around. Okay, but now because it was working in the reverse fashion, so we actually reversed the polarity of the positive negative. So it is working now. And the middle pin, that is the wiper, is actually connected here. So it is connected to V0, which is here now. So this is, we know how to change okay, this is the only thing that we need to change. The other pins, that is the RS pin and the enable pin and the data pins, they remain exactly the same. So normally that is not a very big deal. You just need to worry about where those pins are and what am I connecting to. So just create variables, or you could have just written this statement with I could have written it as, where is my RS connected to? On pin number 2. This is connected to pin number 3, 4, 5, 6, and 7. This would also have done exactly the same thing. Instead of creating variables, I have used it now. Let us run this now and see how it works. It is working exactly the same way. So it's up to you how you use them. You either create variables or you specify the pins now at all those locations. But please remember, the first number is actually the pin number of the RS. Second is for the enable, and the last 4 for the data pins. And please remember, the data pins are either going to be D0 to D7, that means all of them, or 4 of them. We are using 4 of them. This also works fine. And in all our projects, we are going to use 4 pins only, so you don't need to worry about the 8 pins thing. Okay. Although the 8 pins one in Arduino, it works faster. Only thing is you need to connect those 8 pins now. That's all. Everything remains the same. Everything, all coding remains the same. Okay, I think we have done it all for this. And that's all for this video. Thank you for watching. See you in the next video now.